Hey guys, welcome to this session by Great Learning. My name is Anirudh, and in this session, we're gonna check out a lot there is to know about statistics for data science. But then, guys, before we begin with this session, can I quickly get a yes or a no from you guys if you can see the screen properly, and of course, if I am audible to all of the audience right now. So, guys, head to the comment section, give me a quick yes or no for that, and we can begin. All right, I do have a couple of confirmations on my screen right now. So, guys, even before we get started with this session, I hope all of you are keeping safe from the ongoing pandemic, taking all the safety measures that's required, right? Now, guys, one important thing I would highly appreciate if you could hit the subscribe button and, of course, the bell icon next to it so that you are in constant touch with all the content that we're putting out here at Great Learning. So make sure to hit the subscribe button and the bell icon, and of course if you like the content, if you get to take away a lot of it, which I promise I'm going to try my best to give you a wealth of knowledge with this session, make sure to like the video and of course share it among your friends and family members who can make full use out of it. Now, guys, before we dive into statistics for data science, give me a second to guide you about one of the ventures of Great Learning that we have here, which we call as Great Learning Academy. Now, Great Learning Academy is one of these brainchilds of Great Learning, where we are coming up with many courses and certification for these courses for absolutely free. Of course, you can already see we have a wealth of content here. We have so many different courses in so many different domains. So to highlight one important point here is that yes, all of these courses, all of these certifications you see on your screen right now, you can get started with this for free. You can enroll for free, and as soon as you complete learning all of these courses or whatever it is that you are interested in, you can get a free certificate at the end of it as well. I am sure you guys will know what amount of value a certification adds to your resume, to your knowledge, and to your career. Right now, all of these courses are taught by subject matter experts. It's available in more than one language. For example, you can see Python for machine learning in Hindi, and of course we have many languages coming soon as well. And if you keep scrolling down, you can take a look at all of the upcoming live sessions that we have. And of course, if you are subscribed to the Great Learning YouTube channel, you can of course get to know this there as well. There are many ways that you can reach the Great Learning Academy page. We promise to cater for everyone. If you are in college, if you just graduated, if you're looking for a job change, if you're looking to learn something seriously, if you're looking to build upon a wealth of knowledge, just for the sake of it, or whoever you are, right from a beginner to an expert, I do believe that we have something here that you can definitely make use of. And of course, it's free, right? It's absolutely free of cost. I would highly recommend that you guys check this out. You can reach us by going to greatlearning.in/academy, or of course a simple Google search for Great Learning Academy is going to get you to this page as well. There is another way you can get to us using your mobile phones. Of course, we have the Great Learning app through which you can access the academy. You can get it from the Apple App Store and of course from the Google Play Store as well. Now, guys, after looking at the Great Learning Academy, I hope you guys will check out, and at the end of the day, you can use it to power ahead in your career. Now, coming to statistics for data science. What is the agenda of this session? What are we going to cover today? One important thing that you really have to know is about the key takeaways that you're going to get from this session, because it's very interesting. See, we can begin this session by taking a look at what data science is and understanding how the data science life cycle works. once you know how the life cycle works, you'll be looking at the statistical aspect of data science, right? That is where we'll be discussing statistics for data science, all the types of statistical analysis that we can go on to perform, and what exists, all the methodologies. We're going to be asking a lot of questions as well. We're going to take a question answer approach in this particular video when we're dealing with statistical concepts. And of course, guys, at the end of the session, we are going to have an amazing demo as well, hands-on demo demonstrating some of the things that we have discussed in the session. So make sure to stick till the end of the video. Now, guys, to begin with, the first item of the agenda, I'm sure that you guys are excited for. As soon as you look at data science, everyone is excited, right? So what is data science? Why is it this popular? Now, data science is one of these things, one of these immensely popular domains where we use a lot of tools, a lot of methodologies where we can take data from its raw form and convert it into really useful information by making use of computers and the power of computers, right? So, to do that, we use a lot of tools. We have many concepts, we have many methodologies that are backed by mathematics and statistics, of course. And right, it's not only just that; it's all about taking the data from multiple sources. It's about making sure that your data is workable at the end of the day, working with it and producing a result which is understandable by a large audience as well. In most of these cases, this is how we are going to go about working with data science. Now, coming to why data science became this popular, right? See, in the entire world of computer science, the world of IT, this is the number one domain right now, because we need a lot of experts. We need a lot of you guys to actually go on to come and work in the field of data science, because hey, we are generating a lot of data every single day, huge amounts of data, 2.6 quintillion bytes of data get generated every day, and we need experts who can handle that and use it for something for a good purpose, right? And of course, when you think about how you being a data scientist can help the world, well, let me tell you this, the impact that you're going to have on your business, be it a startup, be it a multinational company, or wherever you choose to work to, you will be adding a wealth of value to the particular company itself. So that's very important. And as a data scientist, you will help in reducing all the production costs, because your data is going to tell you so many things which you might have missed as soon as you just look at Excel sheets or a sales data or something. And that saving money is basically increasing your profits to a certain extent, right? And understanding trends and hidden patterns are the most important skill of a data scientist, because at the end of the day, you need to have the current data, have the past data, and try to predict what happens next as well, right? That is a very key part of data science. And guess what, when you're looking at trends, when you're trying to analyze hidden patterns, or when you're trying to look ahead, see, data is one of these entities that acts like a proof, right? You're gonna have the data, and when you make an assumption saying, hey, this is happening, you should have data to prove it. And how do we know this data is accurate or not? We are going to use a lot of statistics for that particular regard. Now, coming right into the heart of statistics for data science, right? See, statistics is the most important aspect there is for data science. For all the people who talk about programming, for all the people who talk about handling a large amount of data, I agree with all of you that programming is extremely important. Handling large amounts of data is important. Data visualization, all of this is beautiful. But if you do not know, see, for example, you can implement a machine learning model to a certain extent, to a basic extent, without not having to know how it works. But to know it in depth, but to know how it completely works, and to understand how it works, right? You really need to have the knowledge of mathematics, to have the knowledge of statistics, because machine learning, especially the field of machine learning, uses a lot of statistics in a way where once you start learning this approach, once you start taking the statistic approach into understanding why your machine learning model behaves the way it does, it's really a beautiful thing. And a lot of people who see this kind of a beauty in the work that they do, they fall for it, right? At the end of the day, me personally, being in the field of data science for a lot of years right now, it's been a beautiful journey. And every day, the field, the people, all you enthusiastic learners, all of you guys always amaze me with your interest towards this domain as well. So it feels really good to be a part of the entire field of data science. Now, Coming back to statistics, you have to know that coming to a conclusion is very important in many of the cases. You're going to have a problem at hand. For this problem, you have to provide a solution. Now, you to provide a solution, there is two ways. One way is to guess, right? You can guess saying, hey, I think this might work. The next way is to say, hey, I know this works and I have the data to prove it. Now, in the case of statistics, what do you guys think? Which of these things align with statistics? Are you guessing or are you providing a concrete conclusion? Right? The answer, of course, is on your screen right now. So I hope all of you guys agree with me, right? So, guys, before we move on to the next slide, I would like to tell you one very important thing. I want to keep this session extremely interactive, so I would highly appreciate you guys, coming to the heading to the comment section, and of course, leaving your views. Any questions that you have, and anything of that sort. So guys, head to the comment section. Let's have a very interactive session. And picking up one comment by a person called Gaming. He says, tell me the best laptop for coding in 35,000 rupees. Well, Gaming, let me tell you this, you are right in time, because we actually put out a video just for this, just a couple of days back. So make sure to head to the Great Learning YouTube channel after this video, and of course, check it out. And right. So Balaji has a request saying, please explain the probability distributions for used in a data science project. Of course, Balaji, this has to be a session of its own, because when you're looking at probability distributions, they are a vast concept. Now, if we do get to discuss about probability distributions in complete detail right now, and for all the beginners and the intermediate viewers who might not know it, can be a little overwhelmed. So to keep the session to the scope of all you viewers, be it beginners, intermediate people, or advanced people, we're going to discuss it, we're going to take it slow, and of course your point is very much noted, Balaji. We will work on the probability distribution. Of course, you do have multiple courses on Great Learning Academy where probability distributions are discussed as well, so make sure to head to Great Learning Academy and check it out. And again, guys, a small reminder, if you are liking the content you're seeing on screen, I would highly appreciate if you could like the video and share it among your friends and family members. Now, coming quickly to talk about the data science life cycle, right? What happens in data science, how does it happen, what's the process, in a very simple and a meaningful way. Now, ladies and gentlemen, you have to understand something here. In any case of data science, in any case of statistics for data science, whatever it is, right, everything begins with a problem. Now, everything that you use came about, every product that you use, every service that you use is basically a solution to the problem in the entire world, I bet, right? So now there will be a certain problem. The current problem of how data science became extremely popular was the world started generating so much amount of data, right? We are just punching in trillions and trillions of bytes worth of data every single day. That was the problem. You needed to handle that. You needed to use that data in a meaningful way. So that was the problem, and people realized that the problem existed. Now, once a problem was existing and people knew it was working on, then they started collecting data about the problem. Since they had a lot of data to collect with, of course, 90% of the data in many cases may or may not be useful, right? It's not just 90%, it can be 5% of data which is being useless, and of course 95 being workable as well. We call it useful data, and we call it noise. Noise is something which you would not use, which is going to hurt every single step ahead in the procedure, but meaningful information is going to add inside. Now, see, what happens in the case of machine learning and statistics is that if you show wrong data to your algorithms, right, it is going to learn using the wrong data. If it starts learning using the incorrect data, what happens is it will you are trained as a human to probably pick up facts, pick up hypotheses, and pick up a concept, and then know that it is either right or wrong, or you can make a very good guess. Now, a machine learning algorithm cannot make a guess like this unless it's been taught to do it, right? So if you show the incorrect data, it's going to learn based on that, and your results are not going to be as accurate as you think it's going to be. So after pre-processing the data, after cleaning the data to make sure it's neat and tidy, to make sure there are no anomalies for the machine learning model which comes ahead, you're going to perform what we call as EDA, or exploratory data analysis. Now exploratory data analysis is this kind of a process where we're going to take in all the data, the cleaned data of course, and we can see and understand all the hidden trends, hidden patterns in it. We're going to see it's basically, data is a treasure trove, right? So you can get you can get a lot of information from data. But if you just look at a data, right, so let me if you're looking at a data set, and I'm going to show you a data set at the end of the session, as soon as you look at it, you cannot really make any sense out of it. But if you are performing EDA, then of course it's going to give you a lot of insight, which you guys are going to see in the session, in the demo of this particular session. And then coming to machine learning and prediction, this is where you're going to train your machine by showing it some data. It's going to understand what it needs to do. It's going to perform some predictions. And once it predicts something, you're going to check if it has learned it correctly or not. If it has not learned it correctly, you're going to retrain it by changing parameters. And after it's all trained and ready, the last step is where you'll be deploying the model to solve your business problem, right? This is a circle. This is a life cycle of how things happen. Now, coming to data science programming, right? See guys, it is very important that you know all the programming concepts first of all before we get into the statistics aspect of it, because you're going to require knowledge about SQL, you're going to need Python, you're going to need a little bit of Java, R programming language, SAS, Informatica, Matlab, and many of these tools as well. So have you guys worked on any of these concepts? Do we have people in the audience who worked on Python, Java, R, SQL, and all of these guys? If you are if you have worked on these, I would highly appreciate you head to the comment section and leave a comment so that I get to know what you have worked on as well. And then diving into the heart of statistics, right? The type of statistical analysis that one can perform. Now, there are two types of very, very important divisions in the world of statistical analysis. It's descriptive statistics and it's inferential statistics. What happens in descriptive statistics is that, as the name suggests, you're trying to describe something. You're going to be expanding on the data that you have. You're going to be making use of mathematics, concepts of statistics. You're going to be making use of graphics. You're going to be making use of dashboards and all to describe the solution to a problem. That's what descriptive statistics mean. Now, to give you a very good example, right? So think about all the sports activities that are popular based on gender, right? Now, when you think about it, I can give you a very small example. Think about, for example, professional weightlifting or boxing. It's usually a male-dominated sport. Of course, that is changing these days. But when you look at the sport itself, the history of the sport, that is how it has been, right? So if you want to track, things like this, and you want a descriptive answer, you'll be looking at descriptive statistics. But then there's another important form of statistical analysis, that is inferential statistics. With inferential statistics, what you'll be doing is that you will be making an inference. Now, an inference is sort of a guess that if one thing happens, the other thing can also happen. Now, to give you an example about inferential statistics, think about this. You are on your favorite e-learning platform, that whenever you're learning on any of these concepts, for example, when you are at Great Learning Academy itself, and I hope all of you guys are signed up for Great Learning Academy. If you haven't, make sure to head to Great Learning Academy and do sign up for the free courses we provide there. So once you finish a course, we actually recommend another course for you there. So this is based on a fact, an inferential statistic saying, hey, if this person has finished this particular course, and this is the requirement to become an expert in the domain in the next step, that is what is provided for you guys, that is what is recommended for you guys, right? So that's an inference. Another very simple example is when you go to a bookstore, you buy a book, you buy a notebook, right? Now there is a very good chance, if you have bought a book, that you're going to require a pen to write it, right? So you might buy a pen just for the fact that you bought a book. So you're realizing that, right? If you buy, or if you work with A, you might do B also, right? In this case, A is the book, B is the pen. This is how it similarly works in the case of inferential statistics, right? So we have Mayuk. Mayuk says, I am learning in Great Learning Academy for the last 6 months. Well, Mayuk, I hope it's really going well for you. Do let us know about your experience. I hope all of the subject matter experts are putting out a wealth of information out there, and you are picking up all of that. Now, coming to the statistical concepts of discussion, right, guys? To even begin with that, one question that needs to be answered is what is statistics, right? The answer to this question I want from you guys. So make sure to head to the comment section right now and tell me what you think statistics is. Of course, you have the answer in your screen, but I want to know your views on the on the description of statistics, your understanding of statistics, guys. So head to the comment section and let me know. Suhail has a question. He says, what's the duration of this particular session? Suhail, this session is going to be for somewhere around 45 minutes. Right, guys, head to the comment section. Let me know what you think statistics is, or what do you know about statistics. Well, if you do not know a lot about statistics, do not worry. The point of the session is to make sure to guide you towards that. But I would highly appreciate an interactive session, and I would love to see your comments coming. Okay, wow. A lot of you guys are answering. All the answers are amazing. You guys are accurate. So you do know the popularity of statistics for data science, and you know what statistics is, right? So it is this kind of a mathematical model. It's an application of mathematics itself. That's why we call it applied mathematics. Now, applied mathematics is basically physics. Applied physics is basically chemistry. Applied chemistry is biology. So, right, this is how the world of science works. But the way of how data science works is we focus really on mathematics here, right? Here we make sure to collect all the data, to assess the data, to analyze it, right? It's not as easy as it sounds. You are going to require a lot of information about that. You're going to have to know how to work with data, how to organize it. Data is a very unorganized, unruly entity, right? There is various types of data. You have numerical data, you have categorical data, structured data, unstructured data, all of these types of data, right? It's important that you know how they are, how they are used and how they work as well. So basically what I'm trying to tell you guys is you'll be using a lot of mathematical computations to eventually get to the result. You're going to see that practically as well. Now, let us begin by answering a lot of questions that you guys might have, right? The first question being, in the concepts of statistics, what is population? What does population mean? Now, population actually refers to all of the observations that we make. Now, if we are trying to observe anything here, now let's have 100 people who are very much interested in buying ice cream. We have totally 100 people. Now, if you look at all of these 100 people and then perform an analysis keeping all the 100 people in mind, that becomes the population, right? It's the entirety of 100 people. Now, if you are looking towards studying a data set such as the diabetes data set to understand what are the symptoms of the people, what are the factors that have a role in the case of the onset of diabetes and all of that, if you pick up everyone, all of the people who have diabetes or not have diabetes, then that is a population. But if you only pick up a few people for your experiment, a few candidates, right, then these guys are called as sample set. A sample set is basically a small chunk out of the population. So this is what population is. This is a foundational concept in statistics, right? So exactly from the image you see on your screen right now, you can understand what a sample is, right? So it's basically a small chunk of the entirety of population. If you have 100 rows of information, if you pick up 10 from it, that's a sample. If you have 1,000 and you pick up 100, that's a sample as well. You do not have to pick the exact number that I've shown you on the screen. If you have 1,000, even if you pick one from the 1,000, that's a sample out of the entire population. If you pick the entire 1,000, that's the population, right? So using these concepts, using samples are extremely popular in the case of statistics, because this is where, see, sometimes, as I told you, the world generates a lot of data. Now, to use all of this data to perform analysis is sometimes not possible. So what do you do when you have a lot of data is, you break it down, you take certain aspects of it. Sometimes these samples are the most powerful entities, which is going to give you a really good result. So Mayuk has a question. He says, sir, are sample sets and sample space the same? Yes, Mayuk, we do address sample sets and sample spaces as the same entity in many cases. Now coming to the next question, it says what are parameters? Well, parameters are the things that we use to describe what the population are doing, right? So what happens is that think of parameters like things that we use to describe population. Now for example, if you have 10 numbers, the average of 10 numbers, the percentage of change in between these 10 numbers, the sum of all of these numbers, all of these things are the stuff of life we are working on, especially if it's the population, right? So we are using that to get an insight, to derive an insight out of it. For example, average of all these numbers can be an insight. So you can think of a very popular example when you think about averages, right? So maybe you've fueled up your car 5 or 6 times. Now when you want to find out the average mileage you got on all 5 or 6 of the times that you used your car, the average, that's a very word, right? So we are using statistics in real life, in a very common aspect as well. Then of course, to look at the parameters of population, you have mean and standard deviation. Mean is nothing but the average of population as well, and standard deviation is again a very good concept in statistics. So guys, do you know the meaning of standard deviation? Have you used standard deviation previously? Let me know. And of course, coming to a quick example of what parameters are, now think about the age in the case of a diabetic data set that we're going to take a look at later. The average age of a person being diabetic can be considered as a parameter, right? Now, in that aspect of it, you're going to take a look at the entire diabetes population. You're going to look at the average age of all the people who are diabetic, and you're going to come at a conclusion saying, hey, this is the average age. So if you, it's not that saying it's concrete, hey, if you touch that age, you're going to get diabetes for sure. It's just a guess which is backed by numbers, which makes it concrete. It's no longer becoming a guess. It no longer stays a guess because it has data now to go on to prove that. Right now, I give you a quick look at what the mean was. Now let's take a look at the other measures of central tendency, which are extremely popular in the case of data science, in the case of statistics. It's mean, median, and mode. Now, when you're looking at mean values, right? So basically mean values are the entities. The mean value in many cases, it's only one entity. This entity is the average value of population. We're going to be doing all of this practically. And when you look at the median value is actually the middle value. Now if you have a 1 to 10 sorted out, right, it has to be a sorted population. If you're looking at numbers, either you can arrange them in the ascending order or you can arrange them in the descending order. And once you have arranged this, pick up the middle element. That's going to be your median. And you might be saying, hey, okay, now if I have even number of numbers, right? See, if you have 1, 2, 3, 4, you cannot pick up one middle number there, because in between 2 and 3 there is no number, right? You have 1, 2, 3, 4. If these are 4 different blocks, there is no middle block that you can pick. So in the case of even numbers, the median is actually the average of the middle 2 numbers. So to find the average of 1, 2, 3, to find the median of 1, 2, 3, 4, what you're going to do is you're going to do 2 plus 3 by 2. That's 5 by 2, which is 2.5. In that case, 2.5 becomes the median there. And then talking about mode is one of these elements which are which are occurring the most in that particular data set. Now if I have a data set that is like 1, 2, 2, 2, 2, 3, 4, 5, mode is going to be 2. Why? Because it is the element which has occurred the most common time, the most number of times, right? That's your basic working of central tendency. And then we have more measures. If you're looking at the measures of spread talks about how far the data is put across, right? We have a concept of outliers. Have you guys heard about outliers? Have you worked with outliers before? Head to the comment section and let me know. So what outlier is in many cases, outlier is a distortion. It's an unusual value. It's an anomaly. So it's an anomaly which is going to have an effect on your process of data analysis itself, because it's going to tell, it's going to, your machine learning algorithm is going to use this kind of an outlier value, which is very far away from all the other values. It's going to use that and think that it is important. So it is very vital that you handle outliers and remove any sort of unusual values which could be affecting your analysis as well. Now in the case of I can give you an example about an outlier. Now if you are taking the weather prediction for 100 days in the middle of a desert, and if it rains 2 days if it rains really heavily in the desert for 2 days, that's going to be an outlier. It's an unusual thing for it to rain in the desert, right? Now, if you feed all of this data to a machine learning algorithm, it's going to think that yes, there was a slight chance that it rained, so there's a good chance it might rain again, and that will affect your value of analyzing how how dry the desert is, or why it doesn't rain, or something like that. So in many cases, sometimes with the data that we had, of course, with weather data, it can be an experimental error as well. So it might be a measuring error where it might have not really rained, but something went wrong with the sensor and it said that it rained and all of that. So these kinds of anomalies really hurt your average value of when it rained, when it not rained, what happened, right? So you can think of a lot of examples for sure. So if it starts affecting your value of mean, median, mode, that is when you really have to know outliers are in many cases, I want to say it's annoying. Right, now talking about interquartile range. Interquartile range is something which is very important, because here we divide the actual data into smaller chunks of data, what we call as quartiles. These quartiles are used to understand how the data varies from each other, how the data is basically spread across, right? So you will have 5 important entities that you have to know. One is the lowest value in your data set. Next is the highest value in your data set. Now, in between the lowest and the highest values, you have we divide the data into 4 columns, what we call as Q1, Q2, Q3. Now, Q1 is basically the 25th percentile of the data set, the data from 0 to 25th percentile, and then we have 25 to 50, which is comprised of Q2, and when you look at Q3 is basically talking about the 25th percentile. Guys, I hope you know the difference between a percentage and a percentile. Percentile has dependency with all the data that keeps changing around it, right? I hope you know that already. So to go on to calculate a measure, interquartile range is a measure, as I mentioned. So how do you measure it? You basically take the 75th percentile and the value that you have there, and subtract it from the 25th from the 25th percentile, which is basically Q1. So Q3 minus Q1 is going to give you a range. It's the interquartile range. So it's not only IQR that we use a lot. You have something called as lower limit and upper limit as well. So you have 2 important formulas. I would highly suggest, if you guys have a pen and paper handy, to note these values down. Lower limit is calculated by the formula that you see on your screen, but to go on to calculate lower and upper limits, you're going to require IQR. So first, finding out IQR. Once you have that, you can basically multiply it by 1.5 and then subtract it with Q1. You're going to get the lower limit. If you multiply the IQR with 1.5 and add it to Q3, it's going to give you the upper and the lower limit, right? The initial and the end point that I mentioned in the previous slide. And then coming to a very, very important measure of in the case of statistics, it's measure of accuracy. Now there are 4 important measures of accuracy, where you call as true positive, where you call as false positive, you have true negative, and false negative, right? Now, in the case of the pandemic that we are living in right now, you might have heard of the term saying, hey, that person wasn't actually positive, it was a false positive detection of the COVID-19 test. Have you heard this term, false positive? Among true positive, among all of these, false positive is something even a person who doesn't know statistics has used a lot. So have you heard the term, guys? Head to the comment section and let me know. And Chandrakant has a beautiful point. Yes, Chandrakant, standard deviation will tell you how far away the data point, each data point is from the mean of it. So once you find the average, you have to find out how much of a value difference there is between each of these values to the mean itself. That is what standard deviation basically is. So again, I'll give you a very good example to tell you about accuracy, because you might have not heard about all the other terms instead of false positive, right? So let's go back to the age where there were dinosaurs, right? So dinosaurs walked upon the earth. In my opinion, they are beautiful creatures, right? They are so majestic in their ways, and the movies have brought them out really well. So here's the situation. There is a farmer who's farming happily, in his village. He spots a dinosaur which is heading to the village. It might be a T-Rex, and of course, T-Rex is a carnivore. It's going to eat people. It's going to eat anything that moves about, right? So To discuss about the measure of accuracy, let's use this story. We have a dinosaur that's coming towards a farmer. The farmer sees the dinosaur where he wants to run back to the village and tell the villagers saying, hey, a dinosaur is coming, let's let's go to safety or something like that. Here is 4 situations that's going to tell you about all the measures of accuracy that we just discussed. The first situation is, there is actually a dinosaur. The farmer saw the dinosaur. The farmer, what he'll do, he'll go to the village. He's gonna alert it, and everyone gets to safety. So what's the result of the situation? There was an actual dinosaur, and the farmer was correct in seeing the dinosaur and alerting the village. Right? This is a proper situation. And then look at the second box on the right. The situation is that there is no dinosaur around. Now the farmer thinks he saw a dinosaur, but there is no dinosaur in real. What he does is he just goes to the village and he tells everyone, hey, there's a dinosaur coming, and everyone runs away for no reason. Farmer here is wrong because he has not seen a dinosaur. This if you can relate to the COVID story that we have right now, you are going to know what I'm talking about, right? There was no COVID infection in the person, but the person went and got tested. The person was told that he or she was COVID positive even though they weren't. Now the result is wrong, correct? Are you getting where I'm trying to get here? This is a very important point. And then look at the third one. Look at this one, right? This situation. This situation basically says that there is an actual dinosaur. There is a real dinosaur, but the farmer doesn't see the dinosaur. He says, hey, there is no dinosaurs. All of you can chill out. What does the dinosaur do? It's going to come eat everyone in the village. It's going to destroy the village. And of course, right? So that wasn't supposed to happen. That happened because the farmer didn't see. Right? And then think about the next measure of accuracy, the last one on your right. There wasn't any dinosaur for real. The farmer says, hey, there is no dinosaur. And now everything is perfect. Why? Because first of all, there really wasn't any dinosaur. The farmer will never have seen a dinosaur because there never existed one wherever he's farming right now. And the village is perfectly fine. So look at the situation. Look at what the farmer does. Look at the end result that you're getting to, right? So it's really an amazing thing when you think about and work with mathematics like this. Now, I did have many comments previously from people asking, saying, hey, hey Anirudh, I find mathematics difficult. I do not understand statistics. I want to work towards data science. Can I do it? Yes or no? See, if you take a learning approach like this, right? If you understand a situation like this, you can work with mathematics. For the people who, we will have a lot of people, of course, who might not like mathematics, who might not like statistics, or they're scared of these concepts. There's a very good chance you either have been taught in a wrong way, or that, there could have been a better way that you could relate to mathematics itself, right? If you might have one or two friends who became really interested in mathematics because different teachers started teaching them, or something happened. They changed schools, they changed colleges, or whatever it is, and then they became a professional in mathematics suddenly, right? Previously, they absolutely hated math. This is the difference. This is how you tell a story. This is how you make an audience understand about the concepts of statistics, in my opinion. And of course, I hope all of you guys picked up on the concepts. If you did not, well, here is what I mentioned about the measures of accuracy, right? The first situation we spoke about, true positive, there was a dinosaur. Farmer tells everyone to run away, everyone runs away. On the right is the false positive case, there wasn't any dinosaur. The farmer simply started saying there is a dinosaur, and he was wrong. On the bottom left, you have a false negative value. False negative is when there is an actual dinosaur, but this guy says, hey, there is no dinosaur. Now, coming to the COVID situation, if a person is infected, if a person has COVID symptoms, there is a very good chance he or she might have COVID, right? But they say, hey, no, I do not have COVID. That's a false negative. There's a very good chance that's a false negative, right? And then when you're talking about true negative is when there will absolutely be no dinosaur. There is no COVID, there are no symptoms, everything is fine, it's been proved by data, and everyone is all right. So this is a very simple example to show you what the measures of accuracy mean. So there are some metrics that you're going to be working with. So you're not going to be always looking at a dinosaur when you're working with data sets, right? This is for you guys to understand. So here are the metrics that you guys will be following. There are 4 important metrics. You have sensitivity, specificity, you have precision, and predictive negative values, and these have certain formulas on its own. So it's TP is true positive, FN is false negative, TN is true negative, FP is false positive. So guys, either make a note of this particular side quickly, or take a screenshot, and of course the video is going to be available for you guys to check out. But I would highly suggest you take a note out of this, because this is a very important concept which you will use in real life when you're working with measures of accuracy. And Madhav says, is this useful for data analysis? Absolutely, Madhav. These are the foundational concepts that you are going to require when you're performing EDA. And to understand why your data is giving you that result, you're going to require all of this to check that. Mayuk says FN false negative is the worst case. Mayuk, I definitely agree with you, because in many cases where I've been working on complex data sets myself, whenever we arrive at a false negative case, right, it sometimes gets annoying to work with it. I'll be very honest with you. Right, guys, let me just grab a quick gulp of water and we can move on. Perfect. Now, coming to talk about hypothesis testing, this is a very important concept. You might have a question in your mind saying, hey, what is hypothesis testing? It seems like a very complex thing. It seems extremely interesting, but I'll tell you, it actually is something which is very interesting, right? Because hypothesis testing is one of these situations where we will make assumptions, based on all the experiments that we have done, based on all the observations that we have in hand, we are going to have a hypothesis, right? Let me give, hypothesis is basically guessing. It's an assumption. Now, way back in the day, I am sure you guys already know this story. People actually thought that the sun went around the earth instead of how the earth actually goes around the sun, right? It was called as the geocentric model, for if you guys are any interested in space and interested in astrophysics, which absolutely I am. The actual way the world works, which you already know, is there is a giant ball of fire, a very interesting ball of fire around which it spins everything around it. So it's the heliocentric model that we use. Now, that was a false assumption, right? There was a hypothesis where people said, hey, no, Earth is the center of the world, everyone goes around it. Right, that was wrong. It was proved incorrect later. Now, coming towards the concept of null hypothesis and alternative hypothesis, if our null hypothesis says no, the sun goes around the earth, it was assumed, it was an accepted fact saying, hey, okay, it might be correct. But then there was an alternative hypothesis which says, hey, no, I don't think so. The earth, is the center of the universe. The sun doesn't rotate around the earth. It's the other way around. The earth goes around the sun, right? That's a contradiction to the original hypothesis. That says the exact opposite thing to what null hypothesis says, right? That is important that you understand that. Now, think about a couple of years back, when you guys were all young, when you were in school, they said, the solar system has these many planets, Pluto being the last planet. And then there came a time when they said, oh, sorry, Pluto is no longer a planet anymore, correct? The first hypothesis was saying Pluto was a planet. It was an accepted fact that Pluto was a planet. And then later they changed their mind and said, hey, oops, sorry, Pluto is no longer a planet, right? So sad Pluto. Now, this is the exact concept of how null hypothesis and alternative hypothesis work. But then to go on to mathematically check null hypothesis and alternative hypothesis, you have something called as the concept of the p-value. The p-value is an important metric which is going to tell you either if you should support or reject the null hypothesis or the assumption that you have in your hand. So what the p-value does is it's going to provide evidence. It's going to give you evidence to reject the null hypothesis in case if it was wrong. Now, a lot of people actually had a kind of evidence where they could reject the null hypothesis saying, hey, Pluto was a planet, was the original assumption. And then they said, hey, this is the minimum requirement, you need to be a planet. Pluto did not meet the requirement, so they had to reject the null hypothesis, right? Suhail has a perfect answer. If p is less than 5, accept the null hypothesis. Yes, that's a very common practice. Mayuk says, I am in 8th grade. In class 3, we studied that Pluto is no longer considered a planet. Mayuk, you are absolutely right? So they just changed the entire thing about the planet. I really feel sad for Pluto. Now, anyway, Coming back, if p is less than 0.5, as Suhail said, null hypothesis is accepted, guys. We have a lot of you guys watching this particular video. I would highly suggest, if you are liking what you see on your screen, do like the video and share it among friends. It would mean a lot to me, and of course, I am confident enough that you guys are picking up a lot of things from here. So make sure to hit the like button, and of course, if you want more content like this, I would highly suggest you guys subscribe to the Great Learning YouTube channel. And now, guys, coming to the actual demo where we will be discussing a hands-on by making use of Python. Let's try to predict a very big medical problem in the world, or it was a very big medical problem in the world before the COVID pandemic happened, which is basically diabetes prediction by making use of Python. Now, to demonstrate this practically for you guys, let me make the font size big so all the viewers tuning in from the phone can see it beautifully. We're going to be using Google Collaboratory, guys. Google Collaboratory is nothing but a simple Jupyter notebook that is hosted on the Google Cloud platform. So when you're working with Python, you will have a lot of libraries that you will be working with, right? For example, pandas, Numpy, Matplotlib, Seaborn, Scikit-learn, and all these, right? So when you're working with all of these, you will have to install it if you're doing it manually. But in the case of Collaboratory, they really do not expect you to do all of that. You just import it because it is already installed. It is already ready for you guys to use. It is really simple, right? So let me quickly give me 1 second here. Let me clear all the outputs so we can check it out from the start. Perfect. Now to use statistics and to use machine learning to see what is the accuracy of a machine learning model that can detect if a person has diabetes or not is what we are trying to do here, ladies and gentlemen. But to do that, the first most important step we have to get to is to import all the libraries, all the packages that we have to work with, right? Because this is one step. If you do it once, you really do not have to go on to do it all the time. If your question might be saying, for the people who have not worked with Python, for the people who might have not worked with a solution such as this, you will have to use all of these every single time you use a particular Python code. To avoid all of that, we just do it all at once. We're going to import all the basic packages, right? For machine learning, for data science, for statistics, you're going to require a library such as pandas. For numerical computation, you have Numpy, where you can work with data of multiple dimensions. You have Matplotlib and Seaborn, which is used to provide beautiful looking graphs. You have Scikit-learn, where Scikit-learn is used mostly for machine learning concepts and all, right? So as soon as we go on to work with it, you will go on to see what we are doing. Now, I told you we're going to work with the diabetes data set, right? But let me show you what the diabetes data set looks like. Now, if you were not performing analysis, if you were just to look at this, let me increase the size of my screen here. Perfect. So if you were to just look at this, can you really make out anything, right? Of course, you have values such as pregnancies, glucose value, blood pressure value, skin thickness, insulin, body mass index, BMI, that is, the diabetes pedigree, the age, what is the outcome. 1 means that the person has diabetes, 0 means the person does not have diabetes, right? Now, when you look at data such as this, tell me if you can make any sense out of it as a person who may or may not know about diabetes, or a person who's trying to predict what the outcome is, right? It is very difficult. Now, this is where I'll show you how we can use Python to do it beautifully. So the second step, ladies and gentlemen, after importing all your all your libraries, is to actually import this data into our working space. I just have to click play, and I have already uploaded it here. Let me just quickly show you. Yes, diabetes.csv is uploaded here. So all I have to do is press on play, and now data. We've used pandas to read the CSV file, and we have the data. But let's actually take a look at what the data looks like. So let's quickly go on to use data.head. Data.head will print the first 5 rows and of course all the columns of the data that we have. This is exactly what I showed you in the Excel workbook as well, right? So we have a lot of things about the data, the levels of pregnancies, the glucose value, or what is called as the sugar value. Then we have BP, the blood pressure, the insulin value, the BMI, which stands for body mass index. 25 is considered to be normal BMI, and you can make one or two predictions right here. A person who has a very high BMI, which is 33, means this person is obese. This person has diabetes. A person with a BMI of 43 with a very high insulin value and high enough glucose value has diabetes as well, right? So you can make basic presumptions like this, but to look at it in detail, we're going to have to understand what is what. So the next thing we're going to do is we're going to print out all the column labels of everything that we're taking a look at, right? So you already know this because you saw the data set. This for your reference, I'm printing it out. You have pregnancies, you have the glucose values, BP, skin thickness, everything until the outcome. The outcome is exactly what we are trying to predict by making use of statistics and machine learning. Now, to talk about the dataset in detail, to look at what the dataset does and it is, right? See, you have two types of data. Basically, you have a lot of floating values where, 23.3 is a floating value, 29 is an integer value, right? So I hope all of you guys know the difference between a floating value and an integer value. And here, basically, with data.info, what we're trying to show from the pandas data frame is saying that, hey, you do have 9 columns in total and you have 768 entries for all of these columns. So it's a pretty big data set, right? I can keep scrolling all the way till 700 and all of that, and you can keep going. See, I'm going. The data is still there. Now if you had all of this to look at manually and come at a conclusion, it's very difficult, but to take a look at it like this, it's beautiful, right? Now, coming to the statistical aspect of what the data what the data set does and what it is in terms of statistics, well, here it is. How many values do we have for pregnancies? We have 768 values is what the count talks about for all of these columns. Then you have the mean value. What is the mean pregnancy value that you have? Mean, the average value of all of the people, the entire population, whose average sugar value, the average BP value, skin thickness, insulin value, the average BMI of this entire population set, right? And then you have STD. STD is standard deviation of how much all of these values vary from the mean. It's the average value of the standard deviation of how much it moves away or how far it is from mean as well. Then you have the minimum value. The minimum value for a lot of these is going to be 0 because that's where we can start at 25%, which is Q1, Q2, Q3 that we discussed, right? The interquartile ranges. Well, guess what? Here are the 5 ones that I told you. Min is where you're going to start with the minimum value. Here we are at the first quartile. 50% is going to talk about the second quartile. 75th percentile is going to talk about, of course, the next quartile or the last one, and then we have max. I'm going to plot a box plot as well. In the box plot, you're going to get a pretty good idea about what we're talking about. Now, I spoke to you about a very important concept where I said, we have to pre-process the data and we have to clean it because data is a very raw entity. It makes stuff a lot difficult to work with, right? Now, in this next step, what we're trying to do is we're trying to check if we have any NaN values. With NaN, it stands for not a number. See, look, we're trying to predict the outcome. It has to be either 0 or 1, right? We do not want categorical data here. Categorical data is something like a string value, which is going to affect our data set. As soon as I run this, it's going to find out if there are any values apart from numbers. Since there aren't any, this means that the data set is decently clean enough for us to work with. It's not going to produce any outliers. It's not going to have a lot of anomalies for us to work with, right? So after knowing that, hey, our data is clean, we can work with it. Now, to print out the average value of every single value in each of these columns, all you have to do is use data.mean. Data.mean is something that you saw exactly here. Let me just move this. This is the value. All of these that you're seeing. If you want to just see the mean and analyze it, this is how you would do it. Data.mean, data being our pandas data frame, which consists of the data set. This is the average value of the entire population. Now, instead of seeing numbers, let's see beautiful graphs, right? So let me just use histograms and plot all of the values for you so you can see multiple mappings on your screen, right? So you have a lot of values of how these values in our data sets are itself distributed, right? Now, you can see the value of insulin, you can see the value of age, for example, of how many people are there with that particular age, right? So from 20 to 30, from 20 to maybe 25, we have a lot of people here. Then from 25 to 30, 30 to all the way to 80, right? So age thing is coming down. And then Priyanka has a question. She says how to import data from Excel to Python. Very good question, Priyanka. If you're tuning in now, yeah, to import the data set into Google Collaboratory, I'm going to be using a pandas data frame. I'm going to be using read_csv. It's a beautiful function which is going to help you to pick up the data sets and bring it into the world of Python. This statement that you see on your screen here does just that. Now, coming back, where were we? Right, so we checked all of these out, we made sure the data is clean, we printed all the mean, we checked out the histograms to just plot all the values to take a look at it. Next, we need to understand something called as correlation. Correlation will tell you everything there is to know about how one value is related to another metric, and for how much of a relation, how tight is that relation, how strong is that relation, right? Let me quickly zoom out a little. Perfect. You're right, we have values from 0 to 0.8 or 0.9. Actually it's basically 0 to 1. Now what we're trying to do with correlation is we're trying to say, hey, if it is at 0, it means that both of these values might not be interdependent. For example, the value of age and skin thickness has nothing to do with the outcome, right? In that particular case, it's marked in black. Now you have very light colored marking as you go up. As this number goes up, as the color scale you can see goes up, right? As when things become lighter and lighter, once you start plotting the x-axis and the y-axis itself, you will get to know that there is a lot of dependency. For example, there is a very good amount of dependency that exists in between the insulin value and the skin thickness value, and of course there is a good amount of dependency with blood pressure and the BMI that you see. There's correlation. Correlation means yes, Suhail is correct. Correlation goes from -1 to 1, but you can have a linear scale set with having a Vmax of 1, and then you can work with that as well. If it is -1, a reverse correlation will mean that the opposite outcome will occur, but if you are having a direct positive correlation, it means that there is a direct outcome of how things happen and why it happens. You're going to understand with two different plottings that you see on your screen. Mayuk has a question. Sir, will these codes be shared? Of course, Mayuk. This Python Jupyter notebook can be shared and will be shared to all of you all. Now, next we need to talk about how many people have no diabetes. So it's basically a very simple for loop that we are running on the last column to see and print the number of people who have no diabetes. So in our data case, in our data set, out of 700 odd people, 500 people do not have diabetes. And then it's in very simple. All we are trying to do is to check if result is 0. If result is 0, it means they are not having any sort of diabetic effects, right? So they are not diabetic. In this particular case, the outcome we got was 500, and then instead of saying result of I is equal to 0, if we make it as 1, it's very simple. Here we're trying to print all the people who have sugar or who have diabetes, right? In this particular case, 500 people don't have diabetes, 268 people do. And then coming to print the count plot with Seaborn, right? See, we use Seaborn to show the graph that we just discussed in terms of numbers here. As you can see, 0, the outcome of people having no diabetes versus diabetic. Now, when you look at the graph like this, it makes more sense rather than seeing data like simply saying that says 506, 268, right? That's my point here. And then what you can do is you can have a subplot. A subplot is going to show you the outcome of if a person has diabetes or not based on multiple criteria. That can be pregnancies. You can have multiple labels. You can have, for example, in this particular case, we're talking about age and looking at another outcome as well. So you can plot 100 different things, and just by looking at the graph without any analysis, you can come to many conclusions. For example, as I just told you can plot with age, and this is the concept of box plot that I just spoke to you about. In case if any of you have not used box plots basically denote the outliers. In this case, if you can see, all of these values are outliers, right? So this is something which is very important. Then you have the minimum value, the Q1 value, the median value, the Q3 value, and so on. Coming to the next aspect of it, to split the data into training and testing data set, we're going to split it 80% where the model learns and 20% where the model goes to test. Then using machine learning, in the case we're going to be using logistic regression. With logistic regression, we're going to be performing predictions. Once we go on to perform a prediction, we're going to have a confusion matrix. Confusion matrix is something that we printed out in the dinosaur example. So if you understood the dinosaur example, you will know the true positive values, false negative values, values and all of that that gets predicted. And if you go on to print a final accuracy score, our machine learning model was 74.6% accurate in working with this particular aspect of detecting how this kind of a model works. And it basically is telling me that 7.5 times out of 10 it's going to predict accurate, right? That's how simple machine learning can be. So guys, with this, I have one last concept to discuss with you, one more minute. So if you're looking for free content about where you can learn more of these in detail, make sure to check out Great Learning Academy. And of course, for videos and blogs, you do have a comprehensively put together YouTube channel at Great Learning, and of course with Great Learning blogs. For all the readers out there, we have multiple content, for all of you, all regardless of where you come from. And then if you're looking for specializations and post-graduation, we do provide all of this. So after your after your current college venture that you're putting out, if you are extremely serious about these domains of data science and data analytics, make sure to check us out. Check out the professional offerings we do provide here in terms of paid courses, because here we are making programs with numerous big names, amazing universities across the globe, such as Northwestern University. We have Ivy League schools. We have many universities. Of course, more of these detail you can get it from the Great Learning website as well. So on that note, guys, you have reached the end of this session. I hope this session was very interesting for you all. I hope you get you got or took away a lot of these things. Thank you for keeping it very interactive. I would love to see you guys again. On that note, I wish you well, stay safe, have fun, and have a nice day ahead. Cheers, guys.